Problem number 1 states, consider a slide projector that consists of a single converging lens. The slide has an illuminated region of 2 centimeters by 2 centimeters, and the screen is 10 meters from the lens. So for part A, they want to know, should the slides be put into the projector upside down or right side up? In other words, is the image inverted? So we'll just go through these one by one. We are going to want to put the slide upside down because, as we can see here, we have our object, which is our slide, and once it goes through the lens, it produces an inverted image on the screen. So we'd have to put it upside down in order for it to be right side up on the screen. And then for part B, they want us to figure out how far from the lens should the slide be placed so that the image has a size of 2 meters by 2 meters, and assume the focal length of the lens can be chosen to make the image in focus. So for part B, I drew another figure here so we could see our variables. Just visualize it here. So we have our object again. Here's our lens, and here's our screen with our inverted image. F is going to be the distance to the focal points from the lens, and then our S is going to be the distance from the object to the lens, and then S prime is going to be from the lens to the screen. So they gave us S prime in the problem, and that's equal to 10 meters. So screen's 10 meters from the lens, and they want our image produced to be 2 meters by 2 meters. So we're magnifying it from 0.02 meters times 0.02 meters to 2 meters by 2 meters. So we're magnifying it by 100 times. And we know that M is going to be negative 100 because it's an inverted image. So if we have that negative 100 and we have that 10 from S prime, we can use our lateral magnification equation, and we can just plug those in. So negative 100 is equal to negative 10 divided by S, and then we can calculate S to be 0.1 meters. So we are going to need to place the slide 0.1 meters from the lens in order to get an image that is 2 meters by 2 meters. And then for part C, they want to know if the focal length of the lens is 0.099 meters, will the slide be in focus on the screen? So for this one here, F is going to be equal to 0.099, like they said. And then for this one, we can use our thin lens equation, which is 1 over S plus 1 over S prime is equal to 1 over F. And again, we can just plug in the numbers that we have and see if those are equal to each other, I think. So 1 over 0.01, or 0.1, and plus 1 over 10 is equal to 10.1. 1 over 0.099 is equal to 10.1. So seems like, yes, the image will be in focus. And then for part D, they want us to figure out if the focal length of the lens remains fixed at this 0.099, how far from the lens should the slide be placed in order to make a sharp image if the screen is moved to be only 2 meters away. So now our S prime is going to be 2 meters instead of 10 meters. Our F is still equal to 0.099, and we can again use that same equation and just plug in those numbers to find S. And this time we get S equal to 0.104. So we're going to need to move it by a factor of 0.004 meters in order to be a sharp image. And then finally for part E, they want to figure out how big will the new image be in this case. So again, we can use our magnification equation and plug in our S prime and S, and that's equal to negative 19.2. So that's going to need to be magnified by 19.2 times. And we started with an image that was 0.02 times 0.02, so we just multiply that and we get 0.385 meters. So our new image will be 38.5 centimeters by 38.5 centimeters. And this all ties into what we're learning in chapter 34, right? Optics. Learning about converging lenses, diverging lenses, lateral magnification. And yeah.